So, how do you measure something you can't quite see? And I'm not talking about anything microscopic. I'm talking about that tiny, almost invisible space between the millimeter marks on a regular ruler. Today, we're going to explore the absolutely ingenious trick that solved this exact problem centuries ago.
Okay, to get started, let me ask you something simple. Have you ever thrown darts? Think about it. Did you hit the bullseye? Or were all your darts maybe clustered really tightly together, but, off to the side? Your answer to that question gets right to the heart of what we're talking about today.
And this dartboard analogy just illustrates the difference perfectly. See, high accuracy means your darts are all somewhere around the bullseye, even if they're a bit scattered. But high precision, that means all your darts are grouped super tightly together, no matter where they actually landed. You can be precise without being accurate. And believe it or not, you can be accurate without being all that precise.
So, before we get to the big invention, let's just make sure we nail down this key concept. Because honestly, understanding this difference is, well, it's everything.
The most important thing to remember is that precision is all about consistency. It's your ability to get the exact same result over and over and over again. Now, that doesn't mean it's the correct result, just that it's a repeatable one.
Let's just put them right next to each other to make it crystal clear. Precision, that's your consistency. Accuracy, that's how close you are to the real, true value. Of course, what you're really shooting for is both, a tight cluster of darts smack in the middle of the bullseye. But in the world of measurement, just achieving that high precision was the first massive hurdle to overcome. Okay, so let's connect this all together by taking a step back in time. I want you to imagine a world where the smallest thing you could reliably measure was just the smallest mark on your ruler. That's it.
Think about what that really means. If you were a craftsman or a scientist and you needed to measure something that fell between two of those little millimeter marks, what could you do? You had to guess. You had to estimate. And an estimate is not precise. This was a huge barrier to any real scientific and technological progress.
This was the fundamental challenge, right? How do you invent a tool that can somehow see into that tiny gap between the markings and give you a consistent, repeatable, and truly precise measurement every single time?
Well, the answer came from a French mathematician and inventor who's really the hero of our story today.
Pierre Vernier. He lived during a time of incredible scientific discovery, and in 1631, he published a paper that was about to change the world of measurement forever.
Now, Vernier wasn't just some academic locked away in a room. He was a practical guy, a military engineer who really understood the need for reliable, tough instruments. And it was this amazing blend of deep theoretical knowledge and real, hands-on application that led him to his brilliant breakthrough. And that breakthrough is exactly what we're here to talk about. It was such a beautifully simple solution to what seemed like a really complex problem. The invention that now bears his name is, of course, the Vernier scale. It's a tool that dramatically boosts the precision of any measurement, and it works using a fancy-sounding concept called mechanical interpolation. But don't let the name scare you. It's really just a clever way of using your own eyes to see tiny fractions of a millimeter.
So here's the brilliant idea. Vernier created a second, sliding scale. But here's the trick. The marks on it are just a little bit closer together, exactly 9/10 the distance of the marks on the main scale. Now, because of this tiny intentional mismatch, as you slide the scale along, only one of its marks can line up perfectly with a mark on the main scale at any given time. And finding that one single point of alignment, well, that's the whole secret.
So, how do you actually use it? It's a really simple 3-step process. First, you just take your main reading off the big scale. Second, you hunt for that one single perfect alignment on the sliding scale. And third, you just add the two numbers together. Let's see it in action.
All right, here's a super basic example. The 0 mark on that sliding yellow scale lines up perfectly with the 5 millimeter mark on the main scale above it. So no need to look any further. The reading is exactly 5.0 millimeters. Easy enough, right? But this is where the magic really happens. Okay, look at the main scale up top. We can see the measurement is just a little bit past 3 millimeters. Now, we scan our eyes along the bottom Vernier scale, and we're hunting for that one line that lines up perfectly with the line above it. And yep, there it is, right at the mark for 0.58. So we just combine them. You take the 3, you add the 0.58, and you get a final, incredibly precise reading of 3.58 millimeters. We just measured between the lines.
And look, this wasn't just some dusty historical curiosity. The principle that Vernier developed almost 400 years ago is still fundamentally important in our world today. The real beauty of Vernier's idea is its elegant simplicity. I mean, it doesn't need batteries or fancy electronics, just some clever geometry. And because of that, its core principle is still a cornerstone of precision work absolutely everywhere. You will find this exact same principle at work in calipers and micrometers in machine shops, in the sextants sailors use for navigating by the stars, and in the theodolites that surveyors use to map out land. It's a foundational piece of technology that's still essential across dozens and dozens of fields. And this quote really gets to the heart of why all this matters so much. Without precision, without that consistent, reliable data that Vernier's scale unlocked for us, modern quality control, serious scientific research, and pretty much all complex engineering would be totally impossible. So, the next time you see a beautifully machined piece of metal, or just think about the insane tolerances required to build a jet engine or launch a satellite, maybe you'll remember this simple, elegant trick of a sliding scale. It really makes you wonder, doesn't it? What parts of our modern world are basically standing on the shoulders of this one brilliant 400-year-old idea?